Hi. So in this video, we are going to be exploring the voltage divider rule. Okay, it's a very basic rule, okay, in circuit analysis, and we're going to start off with this simple circuit. All right. So first and foremost, all right, we need to make sure that we have a closed circuit. So what is a closed circuit? A closed circuit means there is a pathway for current to flow from the positive, okay, through whatever components you have in your design, all right, back to the negative. So this is what we call a closed circuit. Okay, so we have that. Now, what does the voltage divider rule, how do you apply the voltage divider rule? Okay, it is basically trying to, using it, we can find out, all right, the voltage across any component within a circuit. All right, so first we need to be aware of the total voltage that is applied to the circuit, and in some cases, okay, when you have more complex circuits, we need to look at the voltage at a particular section of the circuit. All right, so in this case, this is a very simple circuit. So what we have is we have a 5 volt source. All right, we have a 5 volt source here, and this 5 volts will be distributed across all the components in this closed loop circuit. All right, which means some voltage, okay, will be dropped across the 56 ohm resistor here, and some voltage will be dropped across the 180 ohms resistor here. Okay, now how do I, of course you can, all right, with the components and the breadboard and all, you can build the circuit and measure, all right, but without building the circuit, okay, how do you analyze the circuit just on paper? So that is where the voltage divider rule comes in. All right, and the voltage divider rule basically says that if I want to find the voltage across any resistor, let's say R1, okay, so I'm going to call this VR1. It is the resistance R1 divided by the total resistance multiplied by the supply voltage. All right, so in this case, R1 is 56, all right, and the total resistance will be 56 plus 180 and multiply by the voltage across all the components. So in this case, we have two components, so the total voltage across both these components is the supply voltage, which is 5. All right, and this will give me 1.186 volts. Okay, similarly for VR2, all right, we can do the same thing, 180, okay, because R2 is 180, or 56 plus 180 times 5, and that will give me 3.814 volts. All right, again, when you build the circuit, all right, using the components, you must remember that all your resistive components will have some tolerance, all right, plus minus a few percentage. The voltage may not be exactly 5 volts, it could be 5.01, 5.02 and so on. So the actual values will slightly differ, okay, from the calculator values. Okay, now this application, the voltage divider rule, also brings us to the understanding of another rule or law, okay, and that is basically what we call the KVL. Okay, what is KVL? KVL basically means Kirchhoff's voltage law. And what is Kirchhoff's voltage law? Kirchhoff's voltage law basically says that the source voltage will be equals to the sum of the voltage drops, okay, within a loop. Okay, so if I were to draw a loop here, okay, I have 5 volts as my source, and so this 5 volts will be distributed across the components in this loop. Okay, so if you go ahead and you add up 1.186 with 3.814, you will see that the sum comes up to 5 volts, which is the supply that we have. All right, so in this video, I have explained to you the voltage divider rule as well as the introduction of the Kirchhoff's voltage law. All right, so again, this is a very simple circuit with only two resistors in series. All right, when the circuits get more complicated, all right, then we need to have more steps, all right, to understand and analyze it. All right, so thank you for watching, and I'll see you in my next video. Bye.